In addition to the sum and difference formulas, we actually have another set of formulas. Now I will say that these formulas are not worth memorizing. If you happen to be in some application where you're using these a lot, you'll probably memorize them through experience. But right now, the actual focus of this is really more algebra practice than it is, here's a bunch of formulas that you just need to cram into your brain. So let's take a look at these. We have the product to sum formulas, which take a product of two sinusoidals and turns them into a sum of sinusoidals. And then we have the sum to product formulas, which take sums and turn them into products. Now specifically, notice that the sum to product formula only has the sum and difference of sines and the sum and difference of cosines, but not a mixture of the two. It turns out if you mix sines and cosines of different periods, you have a big mess on your hands. If you mix sines and cosines of the same period, then you could use the methods that were introduced earlier to simplify that. So here are all the formulas. We could actually derive these formulas using just the sum and difference formulas from earlier. In fact, if you plug them in straight into here, you will see that they are going to be, the algebra just ends up canceling out nicely. Down here it's a bit more complicated, but the same basic principle holds. If you turn this into u over 2 plus v over 2, and that into u over 2 minus v over 2, and then make your substitutions with the sum and difference formulas, this will all work itself out for you. Here's an example. Determine the value of sine of 15 degrees plus sine of 75 degrees. I've already written out the corresponding formula. Sine of u plus sine of v. Sine of 15 degrees plus sine of 75 degrees. So our u is equal to 15 degrees, and our v is equal to 75 degrees. Once you identify the formula, everything else is about the algebra practice. You're going to plug things in, you're going to do some manipulations, and you're going to try not to make mistakes. So here we go. Sine of 15 degrees plus sine of 75 degrees equals 2 times sine of u plus v, so 15 degrees plus 75 degrees over 2, times cosine of u minus v, so 15 minus 75, 15 degrees minus 75 degrees, all over 2. Equals, well, the 2 comes along. 15 plus 75 is 90. 90 over 2 is 45, so sine of 45 degrees times cosine of, let's see, 15 minus 75 is negative 60. Negative 60 divided by 2 is negative 30 degrees. All right, well, now we think. Sine of 45 degrees, well, that one's not too bad. That's root 2 over 2. That's a memorized value. Times cosine of negative 30 degrees. A couple different approaches. We could use the negative angle identity to write this as just cosine of 30 degrees. Alternatively, we could think about the unit circle. Negative 30 degrees, let me just draw that here. Negative 30 degrees is going to be in the fourth quadrant. Right? And then you can use our reference angles and take the value of cosine of 30 degrees. The cosine, in this case, since we're looking at the x-coordinate, it will stay positive. No matter how you slice it, cosine of negative 30 degrees is root 3 over 2. And now when we simplify, let's see, 2 of those cancel out. You have 2 in the denominator, root 6 over 2. So again, nothing fancy going on here. We just need to identify which formula and make sure we have the right substitutions, and then execute properly from there.